Okay, in 10.1 in your textbook, it's just the very beginning of conics. Basically, it describes how the four conics are formed and gives you the general equation, and then that's about it. It doesn't even go into any. So I have gone and combined circles with this first section, which is why I've called it 10.1 plus. In your textbook, circles I think are in chapter 1, and we skipped that chapter, so I've just added circles in here so that we can go through some additional learning objectives. So these are the three we're looking at for today. I want you to know what are the different types of conics and how they're formed, and then we'll go into circles, writing the standard form of a circle and then graphing. So what is a conic? Okay, a conic comes from what is called a double napped cone. It's basically two cones placed together at their vertex. And then what happens is you take a plane and you cut into that double napped cone. So I'm going to try, keyword, and sketch what these look like. But you will definitely see better pictures in other places. Your textbook has some pictures, and you can even Google them and see these better. So if we take a plane and we hold it horizontal kind of to the base of this cone, and so that it cuts right through it, the intersection of the two, or basically the cross section, is going to be a circle if that plane is horizontal. So that's your first conic that is formed between these two things. And these four basic conics are going to happen when your plane does not pass through the vertex. So if it does pass through the vertex, what that's called is a degenerate conic. If it would go through just right at that point, if it was horizontal, that would just be a point, okay? Or if it went at an angle, it could be a line, okay? But those are not going to be the conics that we're talking about, though, because those would simplify to a different form. The ones that we are going to talk about stem from when the plane does not pass through the vertex, okay? If we take this plane and we tilt it up a little bit on one side and it cuts through at an angle, it's still going to have kind of a circular shape, but it's going to be elongated, and that's going to form an ellipse. If we keep lifting the side of this plane and we make it kind of a vertical plane, this one is tricky. I'm sorry if my sketches get worse. Kind of cuts through behind. What's going to happen here is it's going to cut through both this first cone and then this second cone down here. And what that's going to look like, it's a hyperbola, and it has two branches. So you can see one branch is stemmed from the intersection with that top cone, and then the second branch is based on the intersection with the bottom cone. And if we are kind of somewhere in between those last two, but the plane kind of comes off the edge, kind of like this, hopefully you can see what that's going to form is a parabola. Okay, so we're going to talk about circles in these notes today, and then the next subsequent three sections, we'll talk about these other three. So the general form of a conic section is a times an x squared term plus b times an xy term plus c times a y squared term, d times x, e times y, and then f will be a constant, so no variable on that one. Okay, so basically what general form is looking at is you've got a 0 on one side and everything else is on the other. And something to note is this b term. Okay, you will not always see the b term, but when you do, I'm going to call this the rotation term. So what this means is in these first four sections of notes, we're going to be writing conics in standard form and graphing them. If you have this bxy term, what that's going to do is actually rotate your conic. Now with a circle it doesn't matter, right? But if you have an ellipse, typically your ellipse will either be horizontal or vertical. And then if you have a rotational term, this bxy, you can have an ellipse that kind of occurs on an angle. Okay, so that's what that point does, or what that term does. So most conics are defined in terms of a locus, and a locus is just a collection or a set of points. Okay, so a circle is a locus of points that are equidistant from a fixed point. So what you do is you have some fixed point, and you measure all of the other points that are, let's say, 3 units away from that point. Well, you get a whole bunch of points that are 3 units away, and it's going to form a circle because they all have to be equidistant from that, what's going to be your center point. Okay, the general form of a point on the circle will be x comma y. The point at the center of the circle will be h comma k, and the distance between the two will be the radius, or will be r. So if you're looking at general form of a circle, it would just have all of the terms on one side and a 0 on the other, and everything is kind of multiplied out. Standard form of a circle is going to look like this. It's x minus h squared plus y minus k squared equals r squared. And the reason we like this form is because you can look at it and see what the center of the circle is going to be, hk. Notice that those are both subtracted from their corresponding variables. And then the radius is going to be r. Okay. So what we need to be able to do is, given some information, we need to potentially graph the circle and or write the equation of the circle. Okay, so this one is going to give us some information, and we're going to write the standard form. So if there's a point on the circle, that point is going to get substituted for x and y, and then the center is going to be our h and our k. So what I'm going to do is I'm going to take the standard form of a circle, which is x minus h squared plus y minus k squared, and set this equal to r squared. Okay, then we can plug in these 4 pieces that we have and figure out what the r squared is going to equal. So our x is 1, h is negative 3, so I'm subtracting negative 3 squared. Then we have y minus k, so that'll be negative 2 plus 5 is equal to r squared. So 1 plus 3 squared is 16, negative 2 plus 5 squared is 9, and so our r squared will equal 25. And so what I'm going to do is I'm going to plug back into standard form, and when we do that, we will want to plug in the center and the radius, but we'll leave x and y in general form. We'll leave those as x and y. So this will be x minus negative 3 squared plus y minus, oops, that's not a y, y minus negative 5 squared is equal to r squared. And that's going to be standard form. Hopefully this rings some bells. You may have looked at equations of circles as far back as Algebra 1, but hopefully this looks familiar. Okay, here's one that's in general form. We're going to get it into standard form so that we can find the center and the radius, and then we will graph it. Okay, so what we want to do to get this into standard form is to group the x's together. So in this case, we already do the x squared minus 2x. I'm going to go ahead and put that in parentheses, but leave a little bit of a space. I'm going to group the y values together, same kind of thing, and I'm going to move any constants to the other side. So I just added 4 to both sides. Now what we're going to do with this is we're going to complete the square for both variables. So for x, if I want to complete the square, we take half of this middle term and square it. So half of 2 is 1, and 1 squared is 1. So I'm going to add 1. But if you add 1 to one side, you have to add it to the other. Do the same kind of thing for y. I'm going to take half of this middle term and square it. So half of 4 is 2. 2 squared is 4. And if I add it to the left, I have to add it to the right. So what we just did is forced both of these to be perfect square trinomials. That for the x's, this is going to factor to be x minus 1 squared. And for the y's, that'll be y minus 2 squared. If I simplify on the right, that will become 9. And you should be able to tell the you should be able to tell the center and the radius from looking at it in standard form. So our center is going to be at 1, 2, and our radius will be 3. So if I want to sketch that, I like to plot the center and then plot 4 points that are 3 units away. 4 is nice because those are going to fall right on your grid. And then try and sketch a nice smooth circle through those points. Alright, that's what it looks like. For this next one, we're going to find intercepts. Where does this circle hit the x and y axis? Well, an x-intercept will occur when y is equal to 0, and a y-intercept will occur when x is equal to 0. So I'm just going to plug those two things in and then solve. So for the first one, if y is 0, I'm just going to plug that in. This will stay x plus 2 squared. This will be 0 minus 1 is negative 1. Squared is 1 is equal to 10. And the easiest way to solve this is by square roots. So I'm just going to subtract 1 from both sides. Take the square root. Make sure that I use both the positive and negative versions. So this will be x plus 2 equals positive and negative 3. And then we'll solve those. I'm going to subtract 2. So if it were positive 3 minus 2, it would be 1. And if it were negative 3 minus 2, it would be negative 5. So that results in 2 points. We'll have an intercept at 1, 0, and another one at negative 5, 0. So those are the two x-intercepts. Like I mentioned before, y-intercepts occur when x equals 0. So I'll plug that in. This will be 0 plus 2 squared is 4. Plus y minus 1 squared is equal to 10. I'm going to do the same thing, solving by square roots. So subtract 4 from both sides. Take the square root. Don't forget about the plus or minus. Y minus 1 equals. And the square root of 6 does not simplify, so I'll just leave it like that. And then add 1 to both sides. So this will be 1 plus or minus the square root of 6. Okay. Since those are the y-intercepts, they will be at 0, 1 plus root 6, and 0, 1 minus root 6. Okay. One more example. This one's going to be a little bit more work. Write the standard form of the equation of the circle that passes through, and we're given 3 points. 0, negative 1, negative 3, negative 2, and negative 6, negative 1. So what we're going to do is we're going to start with general form of an equation of a circle. So for this one, let me scroll back up to wherever my general form of a conic is this one up here. When you're talking about a circle, if it's in general form, your A and your C are both going to be 1. We're not going to have a rotation term at this point, so it's going to be 1x squared, no bxy term, plus 1y squared, and then you'll have the dx, the ey, and the f. And we will talk about what we're going to do from there in the next video. Okay, so we're looking at example 4, and this is the general form of a circle. We've decided that the A and C terms are both 1 because we're looking at a circle. And basically what we have to figure out is the D, E, and F. Okay, so we have 3 points. We're going to plug these in for X and Y, and then basically we're going to solve our system. And we're going to use our fabulous matrix skills from chapter 11 because that's the easiest way to solve a system that's bigger than a 2 by 2. So let's see what we got. We have a point at 0, 1, and I'm going to go ahead and plug this in for x and y. So it would be 0 squared plus negative 1 squared would be 1, plus x times d, so that term is going to be gone, that's just 0. E times y will be minus 1e, and then plus f is equal to 0. Okay, so I'm going to do the same kind of thing for each of these 3 points. For negative 3, negative 2, negative x squared is just going to be 9, plus y squared will be 4. D times x will become negative 3d. e times y will become negative 2e plus f is equal to 0. So now for this one, I'm going to get this into standard form, which just means I'm going to move the constants to the other side. So, oh, and I should do it for the last one too. I didn't even realize. So let me go ahead and write this over here in red. So I'm going to leave the negative 3d minus 2e and then plus f, and I'm going to go ahead and combine the 9 and 4, so that's 13, and then subtract it from both sides, so to get that into the other side. And then for the first one, I should do the same thing. I'm just going to move the 1. I don't have a d term there, but this will be negative e plus f is equal to negative 1. Okay, and then our last point is negative 6, negative 1. So go ahead and do the same thing for that and put it into the Edpuzzle. Okay, initially when you plug it in, you should get 36 plus 1 minus 6, oops, not e, d minus 1e plus f is equal to 0. So then when I get the constants on the other side, that's going to be negative 6d minus e plus f. 36 plus 1 is 37, so I'm going to make that a negative 37 on the right hand side. Alright, now matrices. Matrices give us a very easy way for our calculator to solve a system, especially a large system like this, right? It could be bigger, but I don't really want to solve this by hand. So what we can do is I'm going to set up my coefficient matrix. Remember, I'm going to take all of the coefficients of d, all of the coefficients of e, and then all of the coefficients of f. If I multiply that by my variable matrix, in this case, whoops, no, let's not use x and y, right? We don't need that. In this case will be d, e, and f. That will be equal to, and think about matrix multiplication. You combine each row of the first matrix by each column in the second. So this would be 0 times d equal plus negative 1 times e plus 1 times f. And what I want that to be equal to goes in this top spot, so that would be negative 1. And then we combine the second row with our variable matrix. So it would be negative 3 times d, negative 2 times e, and 1 times f. And I want that to be equal to negative 13. And then the last spot will be the negative 37. The way that we solve a matrix equation like this, let's say that our 3 by 3 coefficient matrix is stored as A, that x, we just typically use x for the variable matrix, is equal to our column matrix B over here. So this is A times x times B, where these three things are matrices. To be able to solve this, we multiply both sides on the left by A's inverse. So if I multiply on the left by A's inverse, the A's inverse times A, those will cancel and just become the identity matrix, times x, so that will be x. And on the right hand side, we need to make sure that we multiply on the left and then with the b, because matrix multiplication is not commutative. It would not be the same if we multiplied the b by A's inverse, okay? So I'm going to store this guy as matrix A, this guy as matrix B, and then we'll calculate the solution. So let me grab my calculator. Okay, so matrix. I'm going to go over to the right to edit matrix A. I'm going to make it a 3 by 3 and put this in. I just paused the video and put all of these entries in. Go ahead and do the same thing because I'm going to ask you for the answer in a minute. Okay, now I'm going to hit matrix again and I'm going to edit matrix B and I'm going to make it a 3 by 1 so that I can put my constants in. Alright, and then I'm going to quit. Wait, I better hit enter. Make sure that goes in there. Okay, quit to my calculation screen. I'm going to call up matrix A. I'm going to take the inverse of that, and then I'm going to multiply it by matrix B. Okay, do the same thing, and go ahead and tell me in the Edpuzzle what you got as the entries in your 3 by 1 matrix. Should be 6, negative 6, and negative 7. So those are going to be our D, E, and F. I don't need the calculator again for a sec. So let's find some room over here somewhere. So I'm going to plug those in. This will be x squared plus y squared. My D is 6. E is -6. And F came out to be -7. And this does say standard form. It does not say general form. So we do have to complete the square and get this into standard form. So go ahead and put that into the Edpuzzle, the equation of this circle in standard form. I'm going to group the x's together, group the y's together, and then move any constants to the other side. To complete the square for x, I'm going to add 9. To complete the square for y, same thing, I'm going to add 9. And so this will become x plus 3 squared plus y minus 3 squared, and 7 plus 9 comes out to be 25. So that is standard form of the equation of our circle. And you could verify that too, right? You could graph this. It has a center of -3, 3. The radius is 5. And it must pass through those 3 points. Okay, go ahead and check it. Class is over apparently. Okay, that's it for 10.1. So I'll see you back in Zoom.